Geometry Unit 9. Let's consider the following figure. What 3D object would be produced by rotating the triangle around line M? That would give us a cone. The radius of 3. Sanjay makes souvenir pyramids by pouring liquid into pyramid-shaped mold. The mold he uses has a base of 10, a side length of 10, and the mold has a height of 10. He wants to make a smaller period using the same mold, so he plans to fill the mold 2 centimeters at the top. What is the volume? Minus 2. Approximate volume of the smaller period, so this would be 8. So we're going to scratch that out because he's going to fill it 2 centimeters from there, and then that would correspond towards 8 right there. So let's see, that's 8 times 8, so that's 64. 64 times 8 divided by 3. What goes out to 170. There we go. So Lena wants to make a paperweight at her pottery class. He designs a pyramid-like mold with a base area of 80 and a height of 7.5 centimeters. The density of clay using is 1.7 grams per cubic centimeter. What is the weight? Okay, so he's a pyramid-like base. The base area is 80. And then we're going to multiply this, 80 times 7.5, and then we're going to divide that by 3. Multiply that all that times 1.7. So 7.5 times 80 divided by 3 times 7. 340 grams. 240. What is the volume of a cylinder with a radius base of 2 and a height of 6? Okay, so the formula for a circle, as we first you'll find, is pi r squared. So pi, the rate r squared. So this translates to pi 2 squared. And multiply that times 6. So we have 6 pi 2 squared. So that's pi times 6 times 4, pi times 24. 24 pi. Units. This oblique cylinder has a volume of 90 pi meters squared, base area of 12. What is the height? Okay, so we're going to first so we're going to have 90 pi meters squared cubed divided by 12 pi meters squared. That's going to be 90 divided by 12. That gets us 7.5. I think that's at 7.5. So you can turn this into a triangle. Say 7.5. And if we know that this is 6, squared plus 6 squared, square root of answer. That doesn't give me a clean number. My guess is they just want 12 or 7.5, which is this. Not the real. This is a bit confusing. The picture provided may be to hypotenuse. Hypotenuse. For which volumes can we apply Cavalier's principle to show that they have the same volume? All the figures have the same height and same base area. A and I think that's when you have the same. Yeah, that's about what I thought. So A and B should be right. Because the height is like this. I think C should also be right because you're changing. It's a circle, not a square, but it should be the same. I'll see why it shouldn't. Yeah. The volume of a square base pyramid has a base area of 30 and a volume of 96. The cones have the same base and same height. What's the volume of the cone? So, cone is 30. So 96 over 30 is equal to 3 1/5. 3.2. And this is 3.2. Actually, it's worse than that. I should multiply this times 3. I don't know why I'm doing any of this. It should just be the same area. It's the same base. The cone has the same base area and the same height. Thus, it should have the same volume. So you get, I don't know why I'm having cubic, so that's repetitive. So you have pi here because you had the same base. But because the base is 30 and it says the cone has the same base, it should be the same. Which, I didn't mean to click there. Which object below could be sliced parallel to its base / face to create a rectangular cross section from its base to its face? This one you'll always get a circle. That one you'll get a circle. Parallel to its base. It's a rectangular base. So if you slice it, its slices, you're going to have square. If it's perpendicular, you get a rectangle right here. But you're just giving me circle, 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 square. The following prism has a base area of 20 pi units and a volume of 120 units. The cylinder has the same base and the same height. Which would be the volume. 20 pi units. Prism has a base area of 20 pi square units. Volume of 120. The cylinder has the same base and the same height. Base times height. That's how you get volume. Base times height. It's 120. That should be 120. How do you try to use Calier's principles to show that two figures have the same volume? The bases are the same, therefore the corresponding cross sections are the same. The figures are the same height, so the volume must be a mistake. So the volume must be the same. So the base areas are the same. That's correct. So I can mark out this. And that checks out. Get a little green check mark. Okay. Therefore, the corresponding cross sections must have the same area. The figures have the same height. The cross sections do not have the same area. The cross sections just get smaller and smaller, and this stays the same. The figures do have the same height, which checks out. Put this in red. So B should be right. Put this in black. The heights are the same. The base areas are the same. Yeah. Yeah.